So let's look at a mixed factorizing exercise. Alright, so question A is 3x squared minus 9x minus 12, and the mark allocation is 3 marks. Now usually most factorizing sums only count 2 marks. So the fact that this one is counting 3 means there is something extra you have to do. Usually it is either to get a common factor, or in your final answer there is still something you can factorize. So then you still have an extra step. Alright, so let's get started with this one. So my favorite way to decide what type of factorizing I have to do is through elimination. Alright, so let's look at what I have. Alright, so the first thing I can cancel out is a cube. Alright, there is nothing to the power of 3, so I know it is not a cube. Second thing I can cancel out is the fact that it is not grouping, because there is not 4 terms. Alright, it can't possibly be a trinomial, so we're going to keep this one open. Alright, it's definitely not the difference of 2 squares, because I have more than 2 terms. And then maybe there is a highest common factor. Alright, so we always start by looking for a highest common factor. So in this case, I have 3, I have 9, and I have 12. Do they have something in common? Yes, they do. Right, in all 3 of these terms, I can take out a 3. So that's the first thing we are going to do. Alright, so if I take out my 3, remember to determine what is left, you take what I gave you, which was 3x squared, divided by what I took out. Okay, I gave you 9x, you took out a 3, so we're dividing with 3. And when I gave you a 12, you took out a 3, so you're dividing by 3. Alright, so this leaves me with x squared minus 3x minus 4. Alright, perfect. You don't have to write the step I wrote here. However, if you're struggling, rather write it and have it correct. Now let's have a look at this part here. Alright, so is there something else I can do? So I already took out my common factor. So all that is left is perhaps maybe this is a trinomial. Very important about trinomial is we remember the standard form is ax squared plus bx plus c. So there has to be an x squared, which there is. There has to be a normal x, which there is. And then there has to be a constant. Alright, so this is in fact a trinomial. Going to quickly rewrite it. So we have x squared minus 3x minus 4. So to factorize this, you always look at the sign in front of your constant first. Now the fact that this is a negative means that one bracket has to be positive and one bracket has to be negative. Now we move on. So let's get the factors of x squared. So that will just be 1 times 1. And the factors of 4 will either be 1 times 4 or 2 times 2. Alright, now let's go quickly draw a table for ourselves. So my first part of the table, I have x and x. In my second part of my table, let's use 1 times 4 first. Alright, so we're going to have 1 and 4. Alright, so let's have a look. If I cross multiply this, I get x times 4, which is 4x. And I get x times 1, which is just a normal x. And remember that my one bracket has to be positive, one has to be negative. So let's see if that combination works. So 4x minus x gives me positive 3x. However, I'm looking for a negative 3x. So let's swap these two around. So let's say x minus 4x. And this in fact does give me 3x. Or negative 3x, sorry. Alright, so having this, I know that my top 2 things has to go into one bracket. And my bottom 2 things has to go into a bracket. So putting this into my final answer again, I'm going to have my 3. Okay, don't forget your 3. My one bracket is going to be x and a 1. And my second bracket is going to be x and a 4. Now remember what had to be negative? My 4x. So if I multiply this, my first and my last term, I get 4x So this has to be negative and this has to be positive. And there you successfully factorized. Okay, let's look at question number B. Alright, so for B, I want us to have a look at x to the power of 3 minus 64x. Same thing, alright? You have 5 methods. Okay, so method 1 is a HCF. Method 2 is the difference of two squares. Option 3 is my trinomial. Option 4 is grouping. And then option 5, is my cubes. Okay, so let's first eliminate what we know it definitely isn't. So it can be a cube. There is a to the power of 3. Okay, so we'll hold on for that one for a moment. We know it's definitely not grouping. Alright, why is it not grouping? Because I have only 2 terms and grouping needs 4 terms. I know that it's definitely not a trinomial because there's less than 3 terms. It can maybe be the difference of 2 squares. Alright, there is 2 terms. So let's hold on to that one. And then let's also check for a HCF. So remember, you always start by looking for a HCF. So at the moment here, I have x times x times x, which is x to the power of 3. And you have a x. So do you see that there's a common factor of an x? So we're going to take out our x, and then I'm left with x to the power of 3 divided by 1x, which is x squared, and minus 64 divided by x, which is 64. Okay, now we don't know if we're done yet, so let's quickly eliminate further. So we already used the HCF. There's no longer a cube. However, now I possibly have a difference of 2 squares. Now just remember your 3 conditions for a difference of 2 squares. First thing, there has to be a negative, which there is. Alright, there has to be 2 terms, which there is. And all my numbers has to be a perfect square. Alright, so the square root of 64 gives me 8, and that is in fact a perfect square. Alright, so let's factorize this then. It's the difference of 2 squares. So I'm going to have the square root of x to the power of 2 minus 64 in a square root. And I'm going to have the same bracket. However, this time it is a positive. Alright, you don't have to write this step, but if it helps you, perfect. Alright, so then we get the square root of my first term, which is x squared, and that will give me x. Then I get the square root of my second term, which is 64, which is 8. Okay, do the same here, then I'm going to get x plus 8. Now, obviously I can see that everything is eliminated, so that is in fact my final answer. Alright, so just let us look at our last example here, or last question. So question C, it is going to be x to the power of 2 bracket x minus 3 minus 4 bracket 3 minus x. Alright, so immediately what you have to see is that here I have 2 brackets. Alright, I have a bracket x minus 3 and I have a bracket 3 minus x. They are almost the same, however my difference is my signs. Here my x is positive, but my 3 is negative. Whereas here my 3 is positive, but my x is negative. I want to switch them around, which means I have to take out a minus. So you know when you have to switch these two around, the sign in front of your bracket has to change. Alright, so this means I can change this as x squared, x minus 3, change that sign so it becomes plus 4. And because I changed my sign, I can flip it around, giving me x minus 3. Okay, and now I see, but wait, this bracket and this bracket is exactly the same. So I'm going to take it out as a common bracket, and I'm going to make my second bracket for what is left. So if I remove this bracket and I remove that bracket, I'm left with an x squared plus 4. Very important, check here. Is this the difference of two squares? No, right, because there is a plus in between. Remember, difference of two squares has to have a minus, so this means that my final answer will just be x squared plus 4. And there you successfully factorized that one.